So the first definition says that for a given sequence, A sub n, its series denoted by summation an which is equal to summation n running from 1 to infinity, is the limit of the sequence. Is the limit of the sequence S sub n of partial sum Are you with me?
Yes, I'm here.
Okay. So the simple logic there, we'll now write it in mathematics notation now. That story. That is for a given sequence an, its series denoted by summation n from 1 to infinity is the limit of the sequence xn of the partial sum. So what we are saying in essence is that is summation an, which is summation an n from 1 to infinity equals to limit of the partial sum as n tends to infinity, which I can say that is limit of summation ak n tends to infinity from k equals to 1 to n. So what we are saying is that the limit of the partial sum will tell us what will happen to the entire sequence, the series of the entire sequence. So that's what that definition is talking about. That if you can get a formula for the partial sum and you take the limit of that, then you've been able to conclude what happens to the entire series of the sequence an.
Okay.
So that's what that definition is saying. You can mute your video instead so that
Okay.
I'll be heavy.
Okay.
So when you're done with writing that, let me know so that we'll now look at the second definition.
Okay. I'm done, sir.
Let's see the second definition. Number 2. This one says, if the sequence of partial sum S sub n of the sequence an is convergent, then the series is said to be convergent. And if the limit of the sequence is infinite or non-existent, in other words, does not exist, then the series is said to be divergent. So if the sequence of partial sum of the sequence an is convergent, then we can say that the sequence itself is convergent. And if otherwise, we say that the sequence is divergent. If you take the limit of the partial sum and you obtain infinity, or it does not make sense in any way, it is a fallacy, then you say that the sequence is divergent.
Okay.
Is that clear?
Yes, sir.
So in other words, what the whole definition is talking about is that the convergence of a series is determined by the convergence of this partial sum for some value k, say. So that's what that is talking about. So I will just give it to you as a remark now. That statement Remark, summation an, n running from 1 to infinity, is convergent or divergent if and only if and only if summation an, n equals to k to infinity, is convergent or divergent. So this summation an, n running from k to infinity, that's the partial sum. So if this partial sum is convergent, then we say summation an is convergent. If this partial sum is divergent, then you say that summation an is divergent. So that's the summary of the definition.
Okay, sir.
And you may be wondering, why are we looking at definitions? Are we not doing maths?
Yeah.
Yes. The definition will help you to solve some difficult problems that you may not really stress yourself. That's why you need to know definition and theorems where necessary. Can I move on?
Yes, sir.
Okay. The geometric series summation a r n minus 1, n running from 1 to infinity, is convergent if absolute value of r is less than 1. Also, the series I believe you remember this formula, a r raised to power n minus 1. That's the nth term formula for GP. So we are now taking the sum now. So that's why we now call it geometric series. So also the series summation a r raised to power n running from 0 to infinity, which is equal to a over 1 minus r is divergent. Is divergent if absolute value of R is greater or equals to 1. Is that clear?
Yes, sir.
Okay. So let's now see how we can use that. When you're done writing this, let me know.
Okay. Yes, sir, I'm done.
Okay. So example 1 says determine if the series summation 1 over 3 raised to power n running from 0 to infinity is geometric. Determine that is geometric and decide if it is convergent or not. Determine if the series is geometric and decide if it is convergent or not. So it's a 2-in-1 problem.
Yeah.
So the first thing is to decide if it is a geometric series. Then if it is, you find the sum to infinity. That's what it means. Understood?
That's it.
You find the sum to infinity. So write the question, then we'll now look at the solution together.
Okay, I'm there, sir.
Okay. Solution. Summation 1 over 3 raised to power n running from 0 to infinity. Let's list out some terms of the series. So when n is 0, you have 1 over 3 raised to power 0 plus when n is 1, 1 over 3 raised to power 1 plus when n is 2, 1 over 3 raised to power 2 plus when n is 3, 1 over 3 raised to power 3, and it will continue like that and so on because it's sum to infinity, so 3 dots.
Okay.
And of course, you know that 3 raised to power 0 is going to be 1. So
Yeah.
that means the first term will be 1 over 1, which is 1. Second
Yeah.
term is 1 over
1
3,
over 3.
plus 3 raised to power 1 is 3.
Yes, sir. 1 over
And
9.
1 over 9.
1 over
And 1 over
27.
27 plus and so on. So that means if you want to include the fourth term, That'll be 1 over 81. So which I can just say is 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus and so on. Now, if it is a geometric progression, there must be what we call common ratio. Now, I didn't give the interpretation of the formula we had here because I believe you are familiar with that already. We already done that before. A is the first term, R is the common ratio. So common ratio is the ratio of succeeding term to the preceding term. So if it is a geometric progression indeed, there will be a constant division, or there will be a common value of division. So let's check that. So first term is 1. R, which is the common ratio. Now, 1 over 27 divided by 1 over 9 will give us 1 over 27 times 9 over 1, which is going to give us 1 over 3.
Yes, sir.
Then, if I do 1 over 9 divided by 1 over 3, that's succeeding over preceding.
Yeah.
That will also give us 1 over 9 times 3 over 1, which is also 1 over 3.
3.
Then the second term over first term, 1 over 3 divided by 1, which is 1 over 3. So you can see that there is common ratio. We can conclude that hence, the series summation 1 over 3 raised to power n running from 0 to infinity is geometric. So that answers the first part of the question. So write that before we now do the second part.
So, sir, because there is a pattern, geometric.
It follows the geometric pattern by having what we call common ratio.
Oh, sorry. Okay, I'm there, sir. I'm there. Oh, okay, sir, I'm there.
Yeah, sorry, Angela, I was...
No, okay, no problem.
Yes. So let's do the second part now. The second part says we should decide if it is convergent or not. Now, if you look at the preamble, we said a geometric series of that type will be convergent if the common ratio, the absolute value of the common ratio, is less than what? Is less than 1,
Yeah. Yes, sir.
isn't it?
Yes, sir.
Okay. So if you look at the common ratio here, since
Yeah. The common ratio is less than 1. Mm.
since R, let me say absolute value now, because it's positive already. Since
Yeah.
R equals 1 over 3 is less than 1, then
It's
the
convergent.
series
It's convergent.
is
Okay.
convergent. The series 1 over 3 raised to power n running from 1 to infinity is convergent. So what does it converge to? We'll now take the second part of our preamble that says that the series a r raised to power n running from 0 to infinity will be what? A over 1 over r. Remember, that's sum, the formula for sum to infinity. So summation a r raised to power n from 0 to infinity equals what? A over 1 minus r. So that will be, our a in this context is 1, the first term of the series, over 1 minus the common ratio, 1 over
Mm.
3.
Mm.
And that will give us 1 over 1 minus 1 over 3 will give us what? 2 over 3.
2 over 3, yeah.
So if you take reciprocal of that, it becomes 3
2
over
over
2,
2.
which is a finite value. A finite value is not infinite and is not a fallacy. Do you get that now? In other words, it exists.
Okay.
It's a finite value. And that's what that definition, let me stroll up so that you will see that that definition, that's what that definition is saying, that so we can, you see the one we have used to answer the first part of the question that says the geometric series this is convergent if the absolute value is less than 1.
Okay. Also, the series is
So,
divergent.
and we have used that. Then here we said if the sequence in the definition of partial sum of the sequence an is convergent, then the series is said to be convergent. And if the limit of the sequence is infinite or non-existent, then the series is said to be divergent. So finding the sum to infinity of this series gave us a finite value.
Yeah.
So we now say that it's convergent. Of course, we have said that it's convergent, so it converges to this value.
Okay.
That's the meaning. So it converges to 3 over 2. So write that. Oh, okay. Do I need to stroll up or down?
No, I'm right there, sir.
Okay.
Okay, I'm there.
Okay. So we have